increasing order. So first one always will be like yes, but EVD gives you increasing order. So
for this method, we should have on the first value to be the maximum.
Yes. Maximum, then lower one, and last one like something equal to 0 or negative. Yes. Maybe it is all because of it. I think.
Well, I tried it even with all repetitions, like without calculating the rank. I just make a loop for the day till the empty, like for the all iteration.
Mm-hmm.
In this case, at least it should be equal to empty, but right?
Yes.
Okay, fine.
So, hello guys, can you hear me? Can you see me?
Hello, yes.
Oh, great.
Yes. Ильдар Айдарович,
Yes.
а можно будет после пары или как-нибудь там вам в Телеграме прислать графики на проверку на адекватность результатов?
Yes, you also can. You also can send me everything by email. Maybe it will be also good. For example, if you send something like PDF file, I will check it. So I will try to check everything today. So I have one thing from Nikolai, but I think we also already find this thing. Yes, already found. Yes, so of course you can send me. And maybe today we will have maybe only one practice. Hello. But because I don't know what else to give you, I will try to check what I have for now with the tasks for exam, and I will check which tasks I already gave you. I will compare something. If I have another type of tasks, I will also give some short examples for this type of tasks. So yes, let me maybe approximately 2 minutes to check it, and we will start. And of course, if you have any questions about homework number 2, you can ask. And let me. Just a minute. So. So I think it is something like practice number 5. So today is 8th of June. So I will give you like a spreadsheet for this task, because if I give you the full version of task, you will be able to solve it immediately on exam. So I will give you like the main idea here. So maybe you will have something like task. Let's call it like task. Task 5 maybe. Task 5. Because we end with task 4 for multi-user Mimo here. So it is something like task for Kronecker model. Maybe you will be given with task. For example, you have something like some covariance matrix of the channel, or in this case, the full correlation matrix of the channel. So something like matrix R, H, and here, for example, matrix of size 4 by 4. So I will not give you the values here, but it contains some numerical parts and some symbolic parts. And here the main question is something like find the connection between the elements of these covariance matrix. Something like something should be equal to something. So find, for example, find the connection between the elements, for example, the elements of. So as reference, I can give you. I have something like this one on my exam, and after the exam, I find it like a Kronecker model, and in I don't remember in which one. There was some web page with the same information like in this task. So you can find this information on internet. So it is open source. And as the continuation of this task, for example, let's say it is something from A up to maybe C sometimes. So here's something like find the connection, what it means, and etc. etc. And for example, like subtask D can be something like, for example, let's assume that you are given by the numerical channel in this case. So for example, 0.6, 0.6, 0, 0, 0.6, 0.6, 0, 0, and have first 1, 0, 0, 0.6, 0.6, then 0, 0, 0.6, 0.6. And for example, For example, we can first ask you, can we represent this type of covariance matrix of a channel using, for example, chronochrom model? Okay, great. For example, thank you. So maybe something like the question, can we represent this type of, let's call off channel, because it is also the connection between the channel and covariance matrix of the channel using chronochrom model, for example. And usually it is two possible points here. First one, yes, and you should explain why it is yes, and you can use this chronochrom model, or no. And also you should explain why we cannot use this type of assumption. So yes or no, explain your point, for example. Then I think you can see that we can use, in this case, chronochrom model. And sometimes we can ask you if we can use this chronochrom. Okay. So also okay. So I think I can continue my thing here. Sometimes we can ask you if yes, so how we can construct our transmit and receive covariance matrices. So for example, if yes, also if yes, what is the, or what are, in this case, maybe, what are the covariance matrices at receiver side and transmitter side. And here you should just give your answer like RR should be something like this one, and RT should be something like this one. Okay. One example of a task is the same to our homework number 3. So if you look to the previous practice, we can give you some Mimo channel, for example, 2x2 or 2x4, and etc. And we will ask you how we can write these R's explicitly. Then we can continue it with the question how we can calculate this decision variable, and of course how we can find this H effective. Then you will also use something like this one. So write R, R2 conjugate, R4, 3, R4 conjugate, etc. And the last part here can be the question about the improvement when we compare signal to noise ratio after the equalization, and if we check it with original row. So it is something like eta divided by rho. Maybe I will show you this thing from the lecture. And I think it is all types of tasks. Of course, there can be some changes, maybe some additional subtasks. So, which one? I think lecture number 9 or 10 in this case. Myself, this one. Lecture number 10. Mimo. So, for example, we can ask the improvement between the signal to noise ratio between this eta after all equalization things divided by this rho. So, for example, for this case, we can say that improvement is equal to this Frobenius norm of the channel squared divided by 2. So, yes. And it is the last subtask for this type of tasks, I think. So, what's next? I will try to end all slides by the next Monday, and I will send it to you. If you, for example, want to find something additional for you from these slides. What is next? What is next? Also, of course, if you want, on next week we can create something like short meeting with questions. If you have some questions through the lectures or related to slides or related to practice, you can of course ask me. So maybe you can make short meeting of your group mates, collect all questions, and maybe send it to me as PDF or like chat me that you want to have this meeting, and for example, we can make it not on Monday, because I think you have first exam on 15th. So 1 week, yes? Next week? So for example, on Friday, if you want, if you have enough time at this day. This one.
Ильдар Айдарович, а
Yes?
какой у нас вообще будет экзамен? Как у Харда, чтобы не решили все, или как в КАИ, чтобы все решили?
I think it will be something like 4 or 5 tasks with maybe, if 4 tasks, it is usual overall 20 subtasks, 25 maybe. If 5 tasks, it's also overall subtask will be 25, something like this one. So, and why I want to make like this one, because I want to give you some chance to solve something, because sometimes, yes, it is very stressful on exams, and you can forget something, or etc., and there will be enough tasks and subtasks in these tasks, so you can get some little bit points to pass this exam. So I think it is better to do like German version of this exam, and maybe I will think about the adaptive scores. So maybe I will give the maximum score to one who solve the maximum amount of tasks, and from this guy I will adaptively give another scores. So I need to have short meeting with Artur Kamilevich and Alexey Alexandrovich about this one, because of course I will I give you these lectures and practices, but I should like talk with coordinators to make everything properly. And maybe if you want, we can continue homework number 3, like how we can do this type of homework. So if you remember, we end with this last subtask. We have to code something on MATLAB, and here we can see this Mimo system. We use QPSK scheme, and we transmit some symbols. And here we assume 3 different cases. Number of transmit antennas always equal to 2, but number of receive antennas increased from 1 up to 2, and the last one is equal to 4. And here we want to see how the bit error rate will change when we increase, for example, signal to noise ratio. And maybe let me open, of course, MATLAB first. And here I have this template. Bit error rate. Let me check this one. And maybe if you have now questions related to homework number 2, you can ask me now, because we waiting this MATLAB to start. So one question was with these eigenvalues. So yes, I think the main solution is just to rearrange the values of eigenvalues. And yes, the main idea here, it is better to plot capacity over the signal-to-noise ratio in logarithmic scale, so in dBs. Because if you plot it in linear scale, it will look a little bit different. If you use, for example, logarithmic scale, you will have something like exponential function. But if you use linear scale, you will have something like logarithmic, I think. So the differences between the lines are the same, because it is just how we plot our results. But I think it is better to use this SNR in dB, yes. So yes, of course, if you use singular value decomposition of H, you should, in this case, not lambda in power of 2, but sigma. So lambda will be equal to, let me show you. You should use something like, for example, sigma is equal to SVD of our channel. And then when you recalculate it to lambda, it is sigma, and of course with point here, oops, sorry, dot, like this one. So you should take sigmas in square to get the proper values of lambda. And if you use, for example, lambda and eigenvalue decomposition, in this case, let me check, it is something like sort on MATLAB, but with additional parameters, something like sort your lambdas, and with like decrease or increase or ascent, I think. So yes. Yeah. Hey. Input arguments. No. Okay. Not the dimension, this direction. So so I think it is enough to use like lambda equal to lambda. but with addition thing here, using this one, like this one. So if you use eigenvalue decomposition, it is better to sort after you get these lambdas. And if you use singular value decomposition, you should use in the power of 2. Yes, yes, or use flip, for example. Yes. Yes, it is better to use flip because it will give you just from end up to the first one. But if you will use sort, it will check all the values inside of this lambda vector in this case. So homework number 3, and we are given by this template here. And let's try to so yes, we end with this thing here. So maybe okay. So we create QPSK symbols. In this case, we create only 2 QPSK symbols because we want to use Alamuti scheme. So we will transmit first symbol and second, and then we will transmit minus conjugate over second symbol and just conjugate over first symbol. So let's check what we should do next. So here we create noise at the receiver. Maybe let's check this one also to the correctness. I think it is all because the sigma here. So let's, for example, change it to 1. And here we have, yes, 2 values, right? Then we create receive symbol as y. We multiply our channel by the transmitted symbols. Why we here don't use the scale factor? Because we already scale in this part. So we say that x is equal to these symbols, and here this scale factor. Yes. Yes, yes. If you use SVD, you will get the first element, the maximum one, and the last element, the minimum one. But if you use eigenvalue decomposition, it will be vice versa. First element, the smallest one, and last element, the biggest one. Yes. So it is all if you only use eigenvalue decomposition. Yes. So here we should write the equivalent channel. So we should generate H equivalent. So let's maybe start with Mimo scheme here. So we have here Meister case. And for example, you can open lecture number 9, and you will find how we can construct our effective channel. So it is I will write it here. What we have. So H equivalent. First, let me check H21. Yes, we created here. Great. So H21. The equivalent channel in this case equal to H1, H2, and then second row it is H2 complex conjugate and minus H1 complex conjugate. So let's write H21 1, then H2 2, and the second row. First we use the second element conjugate here, and then minus conjugate of our channel element with index 1. Let me check the chat. Yes, in this case, we can B times B Hermitian is equal to B Hermitian times B. So in this case, we can use B Hermitian times B. It is okay, but in general case, we should use, no, for SVD, we just use B without this B times B Hermitian. For SVD, we can use our channel directly. So it is not correct in this case. So it is just SVD of B should be in this case. It is all if we use eigenvalue decomposition. Next, we should write combining at the receiver. So it is this decision variable Z. And if you remember, it is just the Hermitian of our effective channel, and then we should change our receive symbols, like first element the same, but second element with complex conjugate. Or let me check. Yes, yes. So let's write H equivalent to 1. We take the Hermitian of it, multiply it by so by 2, 1. First, let me check what we have for H21 here. H21. So yes, it is 2 elements. And we can write here just first element of receive symbol, and then complex conjugate of the second element. But let's think about this part. So H equivalent. If we multiply, so we should write it in one column. So not row, but column. Then we want to detect our symbols. So first we take the real part and image part of this decision variable, and then calculate the number of errors here. So we set this NBE to 1 equal to 0 here before the loop from symbols. And here we sum Mhm. So we check, like check the absolute values of error here. Okay, maybe we can try to, let's check. So let's for this one. Let's comment here, and let's check step by step this algorithm for MISO case 2 by 1. Let's try to run this algorithm here. Yeah. So here we create our signal. Then we create the noise vector. Then we calculate the receive symbols. Then we create, based on, we assume that we have this perfect channel state information. We create effective channel. Then using this something like linear filtering matrix, we calculate our decision variable here. Then take the real part and imaginary part of this decision variable, this one and this one. And the last thing here, we calculate the bit error rate. So maybe first, let's check what we have. So for example, we transmit symbols X here, or not X, but yes, capital X. But we will check our Z with this thing here, with original create symbols. Let's check S, and our received or this decision variables Z21, 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 this one. Of course, we have here some problems with scaling. So first we create 1 plus imaginary 1 and 1 plus imaginary 1. And here we get 1 plus imaginary 1. So first symbol transmitted without error. And you can see that second one, we assumed that this one is equal to -1 plus imaginary 1. So we should have only one symbol error here, I think. Let's check. Yes, you can see NBE equal to 1 in this case. So it is only for this first symbol. And let's try to end this code for cases 2.2 and 2.4. So I'll comment this part. And here, as before, we create noise symbols. We calculate the receive symbols. And here we should write down our channel effective. In this case, I propose you to check, I think, lecture number 10. So first one, it is channel is unknown to the transmitter Mimo case. And here you can see that we have channel effective 4 by 2, but if we calculate the Hermitian of it, it will be 2 by 4, of course. So let's create this one. And I will use my lectures here. So H22. Maybe I will use here. So first row, it is H22. to 1 and 1. So first element, then second element, and the same but the second row. So it is the first part of our effective channel, but then we should create this conjugate thing. The first part is H12 complex conjugate. Maybe we can use, okay, let's use this conjugate operation here. Then we should write minus conjugate of H2 with element 1, 1. And the same thing for the second row, but with index 2, 2 and 2, 1. And maybe for clarity, we can, for example, move it like this one, like this one. So let maybe one more time run the sphere here to show also the lecture part. So we create this effective channel, and next we should write down Z22 for decision variable for Mimo case with 2 receive antennas. So it is the same to H effective Hermitian times our receive symbols, but of course we should change receive symbols with complex conjugate. So we use the Hermitian of it, multiply by, so in this case, here, yes, thank you. Great, yes. And here, oh, now I can show you the lecture side of the same thing, what we code using MATLAB. So this one, for Mimo 2x2, we create this channel effective. And you can see the same thing on in code. Then we should create this variable y. So we write down y1, y2 with indices 1 and 1, and then, so it is first time slot, and then second time slot we take this complex conjugate. So let's write, and maybe first of course check which one will be y1 and y2. If we represent our channel H22 like this one and this one, so okay, we just use first row with same but complex conjugate things, so the same values, and then and of course we should write it as the column. Then we use 2, 1 complex conjugate, and complex conjugate of 2, 2. And of course, right now we can, for example, comment this part. And let's check step by step this first Mimo case here. So yes, we receive our vector y22. Then we create our effective channel. Great. And then we calculate our decision variable. And let's maybe, as before, check what we transmit and what we assume that we received. So it is the same variable S transmitted, and we receive Z22. In this case, you can see that we have also one error in this real part of the second symbol. So we assume that it is 1, 1, and 1, 1. But here 1, 1 and minus 1, 1. And let's check. NBE22 also, yes, with this one error here. Great. And let's do the same thing for case with 2 receive antennas, or 4 receive antennas. The last part here is just to write our effective channel one more time and decision variable. So I think it will be the same, or maybe we can also use, let's check. Let's check our practices, because as I remember, we already assumed this case. Or not practice, but homework number 3. If we check it, yes. So you can see here we already assume this Mimo case 2 by 4, and we write explicitly all the elements from R1 to R8, and we use this type of edited received symbols. But I think in this case we should use not like this one, but let me check. I think it will be something like H1, H2, H3, H4, H5, H6, H7, H8, and after that only the complex conjugate things, because here we write it a little bit different in comparison with our MATLAB code. So I think in this case I can write the full matrix first, so H11 and H12, then H21, H22, then third row, and the last row with index 4. And then we should create this complex conjugate. It's all because of these differences, because here we write it a little bit different. So let's check it. So first here we use H12. This one complex conjugate. And here we write H11 minus complex conjugate. And let's write the same things for second, third, and fourth rows. Second, third, and fourth. And fourth. And of course, we can use same thing as before. For clarity, yes, here we can remove semicolon. And let's, as the last element, calculate our decision variable. So equivalent, and here we write our receive symbols. Let's maybe first check it. What we have here. So what we have for Y24. Strange. Maybe one more step. We have no this. Of course, sorry. One more time. So we have complex double 2x4. Let me check what we have here. Our channel of size 4x2. We multiply by our transmitted symbols. 4x2, 2x2. And maybe, okay, maybe we will rewrite a little bit our code, because I think here we have, let's compare it. So first we multiply first row with two symbols here. Okay, I think I found our mistake. We should write X, we should transpose it, because first we transmit the same elements, but yes, so we should transmit 1 and 1 as column first, and 1, okay, so let me just change this part. I think we can use here X, just transpose without complex conjugate. So I think here also was one mistake in this template, but maybe no, we can check it, of course. So now, yes, we transmit first this part and then this part, but you can see that we have the same strange thing, that our S always equal to 1 plus 1 times J. So here we should change this part to 1.5 and this one to 1.5. Now I will think we have, yes, QPSK symbols. Right, QPSK symbols. Different one. Great. So transmit X. Let's check what we have here. So, for example, we assume our Meister case MR by MT, so 1 by 2, and we first multiply it by our first symbols and then second symbols. So what we have here, so yes, we should write the same thing as this one. So yes, I think here everything is correct. Okay. And maybe here, yes, this part is also correct. Then we assume 2 by 2. And in this case, yes, here I think we have one typo, because this part. Because here, first element with index 1 and 1, it is the case when our channel is with first row and we transmit first column. And element with index 1 and 2, we have this first row and second column here. But we should take the complex conjugate, if you remember, of this second column. So, but also we can move it, I think, yes. If we construct our effective channel as this one, we can move our variables in these time slots. Let's check it. I think we can do it in this way. And maybe last thing here, just check the size of our Y to form. First times load, second times load, third, fourth, and etc., etc., etc. And here we have. So let's try it. First one here, then second element, third, like this one, then fourth, it will be a little bit complicated here, okay, but let's see, 4 by 2, yes, we should, first, yeah, it is really complicated because it is better to use our notation from previous part with our hand notes. Maybe let's try, okay, just as checking here, let's try to create this thing using our previous results. So 1 1 1 2 2 1 2 2, and this one here. Okay, and in this part, first we write 1 1, then complex conjugate of 1 2. Maybe also let's use notation like this one. Then we write 2 1, the same element, then conjugate of element with index 4, so it is 2 2. Then y2 4 3 1, and maybe use the same thing from this part here. And 4. So what does it mean? We have this equation for our receive symbols, and we write it as R1, then R2 complex conjugate, R3, R4 complex conjugate, and etc. And we have this type of effective channel here. Let's try to calculate these things, and let's see our results. Maybe I did a typo here, but we will see. And what we have here, we have 50,000 of transmitted symbols. We have 4 different signal to noise ratios, and we have 3 different channels. So let's wait our MATLAB to run this algorithm. And maybe it will be great if we add here something like additional text to see on command line that our calculation goes. So let's maybe check what we have here. Oh. is not the end thing here, I think. Ah, okay. So it looks a little bit strange for case 2x4 here. Let's check what we have here. 2x4, 2x4. I think we should check bit error rate channel 24. Yes, it is somehow equal to 0 and 0. Maybe it's all because of this construction of channel effective. I think maybe if we use previous one, what we should write here. So. And of course, I can check my codes from previous year, maybe. So to find the small typo in this last part, let's maybe check. Which one? Maybe this one. This one. Edited one. No. Okay. Or in results, not that one. Maybe this one. Yes, and in this case, I use it's really strange, but maybe it works. And you can see in this case, I use not conjugate operation, but just this small prime sign. It is also can be used like this one. Okay, maybe let's try this part of code here, for example. Like this one. And for Y4, I just use the vectorization. Okay. Vectorization. And maybe let's first reduce the number of these symbols here. And here an information, something like f print f. Maybe also in this part. This part. F print f. Channel number, and here we should add something like index d, and signal to noise ratio is equal to also index d decibels. And here we should give an information about this index d. So first one, it is our channel loop, and second one, it is our signal to noise ratio in dB. And f print f, of course. F print f. So let's check. And in this case, we have the problems. Okay. Let's check what we have here. Yes, this one for 2 in this case. Okay. Let's rewrite this part for h24. One, two, three here. Maybe like this one. Let's check. Okay. I should add also here something like In this case, we have very strange results for 2x4. No, it's not correct in this case. I missed something here in this part. I don't know what, but maybe what else? What else? Maybe I will check it by myself after this practice. But here just one small typo. But in which part? I don't know. Okay, I will check it by myself. I don't know. Do we need make another practice after this one? If you have some questions, because right now I already gave you all example tasks for exam, and also the last part here only this code. If you want, you can be with me to end this part, but maybe we can also end our practice. And yes. No, I can't. I cannot give you like the full example of task. So in these practices, I give you something like more than 1/2 of all tasks. So it is something like 75% maybe. So if you know how to solve these tasks by these examples, you will like collect at least 75% of all points on exam.
Sorry, and what about the last remained 25%?
Yes, and this last 25%, it is all based on your knowledge on these lectures, because it's not something really hard, because we will give you subtasks step by step. So for example, first, let's, for example, if we look to the task number 2, maybe for this part. Yes, for example, let's assume that you have something like task 2 on your exam. So let me show you. So all tasks are, or maybe all tasks give you an information and some questions step by step. For example, first we give you Mimo channel, we give you single rail decomposition, and we say, okay, let's first, for example, compute open loop capacity. You compute this open loop capacity. Then we ask from you what we have for these signal to noise ratios. Then we go to plus infinity and minus infinity. Then first step, it is water pouring algorithm, for example. Then this critical signal to noise ratio. I think this one here, critical. And maybe after this one, we can ask you something about how we can get this open loop capacity from which part, because we somehow should find these pre-coding and decoding matrices, and we will ask, for example, what is it, how we can find it. So it is all step by step. So how to say it? We want to give it as understandable as possible. So it is not something like, okay, get these tasks and do it how you can do it. Yes, we will give it properly, in proper way, and you can, for example, say, oh, I can calculate it, you calculate it. When you see second subtask, you see that this one goes from previous one, and you can also calculate it, and etc. etc.
Can we have the sheet with the formula?
Yes, yes, of course you can. You can create this cheat list. So I think I will give you maybe, let's, for example, 2 pages A4, and you can write it on both sides. And this one is all your cheat lists. So you can write everything you want, something from lectures, maybe something from practice, maybe something like algorithm, how to maybe solve this task. Of course, I recommend you, for example, write algorithm of water pouring, because maybe it will be stressful for you and you will forget something, and you can check it and say, okay, now I can use our water pouring algorithm. What is else? Maybe some information about diversity and array gains for different cases, for different systems. I think it is also will be good multi-user Mimo. How we can use this multi-user Mimo, which constraints we have, how we can use block diagonalization in which constraints, then step by step with projection matrices, how we can recalculate it using h time p, and from this one, how we can get these pre-coding and decoding things. What's next? From the beginning, of course, it might be useful to write something about Kronecker model, maybe some properties if you want, like how if we, for example, multiply identity matrix by matrix and another one matrix by identity matrix. And maybe one more thing here. then we assume additional line of sight component is also a good one, because maybe you will have something like we have some channel, we assume that we have line of sight and non-line of sight part, and we will ask you which part is line of sight, which part is non-line of sight, how we can, for example, rewrite this non-line of sight part, maybe using chronochrome model or something else. So it is all, you can write everything, like, of course. What else here? Maybe something from capacity things, like what we have in open loop and closed loop. And of course, you see that we already solved 2 different tasks with this open loop capacity, two different tasks. And maybe, yes, that's all, like, from cheat list. And also you can add additional information for you if you are interested in eigenvalue decompositions, singular value decompositions, if you want. If you feel that this part little bit hard for you, I don't know what's next. So all what you want. Maybe another questions about exam or homework? Yes, maybe that's all. About theoretical part, I think no, not like something like, maybe little part of explanation. For example, like this closed loop, how we can use it, in which conditions, like only this one, not something like let's check that this part is equal to this part and you should do it by your hand. I think I will not give you some tasks like this one, theoretical things. And of course, we can make another meeting, for example, Friday, next Friday, if you want, if you will have some questions regarding to the exam or regarding to the lectures. And maybe, I don't know, I should check one more time this task. Maybe you will have just one subtask related with probability of a symbol error, but I'm not sure. So you can also add this information on cheat lists. So yes, maybe that's all. So if you want, you can still with me here, because I want to end with this practice number 3, because I know it is really easy thing, but we should check just the part of this code, what we have here. So yes, thank you for today, and thank you for this hybrid type of lecture. So now I will continue this part. Maybe it will be better to write. What we have here. For example, we have transmitted symbols X. So X, first one X1 and X2, then minus X2 complex conjugate and X1 complex conjugate. What we have this channel 4×2. So it is something like H11, H12, H21, H22, H31, H32, H41, H42. We multiply by this X1 and X2, and minus X2 complex conjugate, X1 complex conjugate. Like this one. Matrix Y. Goodbye, goodbye. Goodbye, goodbye. H1, 2, X1. So, guys, are you here?
Yes.
Okay, so if you want, you can still with me, and maybe, of course, we can switch to Russian if you want, and maybe I can show you. Oh, not this one. Sorry. This one. So we have X1 and X2 first. We transmit minus X2 complex conjugate and X1 complex conjugate. Here we have channel H1, H2, H11, H12, H21, and etc. and etc. So now I calculate this matrix Y explicitly without the noise vector. So let's write like the noise. So what we have here? First, H1, H2, X1, X2, and this one. So we have this part. Then H21, X1 plus H22, X2, boom, 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 minus H21, X2 complex conjugate, and plus H22, X1 complex conjugate, and etc. The same thing. Now we want to construct channel effective. So we take the complex conjugate. First one still the same, then complex conjugate of the second, third the same, complex conjugate of fourth. So maybe we have, yes, maybe I know what we have here. So, of course, we can check this complex conjugate sign first, maybe. Let's, for example, 1 plus j. We take Hermitian. Yes, it is just complex conjugate. But, for example, if we write like this one, yes, I think it should be correct here. So, I think the main typo is here. When we write just y2, 4 with vectorization, because we should create another type of receive symbols here. So let's try to do it. So we leave first element the same. Then we take the complex conjugate of the second one, like this. The same thing for second row. Same thing for third row. And for the last fourth row. And four. Remove this one. Yes, of course, we save it. We can clear our breakpoints. So we create our H effective. One. Yes, like this one. And maybe it will give us the right results. Let's check. So I leave 10,000 of symbols for the first time. And maybe, of course, we can check. We can check this part. I think maybe we can have one typo in this part. So I will open my homework number 3 and show you. So this one is for case 2 by 2, not 2 by 1 by 2, when we have received only one symbol. But we can see the main thing here. If, for example, we have only one receive antenna, we can remove this part, like this one. And in this case, our effective channel will be H1, H2, and here H2 complex conjugate minus H1 complex conjugate. Let's check this part first. So H1, H2, and H2 complex conjugate. Write it maybe with this. prime sign right now. And here we have minus H21, first element, complex conjugate. So here we have a correct thing. So maybe let's use prime sign here. So everything for 2 by 1 or 1 by 2, it's better to say, we have correct, yes. Now, here. So first I will show you in our practice, we have to construct this type of effective channel. So first it is H11, then H12, then H21 complex conjugate minus H11 complex conjugate, and then the second rule, H21, H22, H22 complex conjugate, and minus H21 complex conjugate. So let's create this one. H11, H12. Then we write H22 with index 21 complex conjugate and minus index 1 and 1. Sorry. Here one small typo. 1 1 1 2 1 2 1 1. And the same thing for the second row. So let's repeat this part. 2 1 2 2 2 2 1. Close this one. Okay, great. The last part here, this one. So let's remove this part. So first element 1 1, then 1 2 complex conjugate. Then 2 1 and 2 2 complex conjugate. And I think that's all for this homework number 3. So we can check it. And of course, maybe you already see this type of code. So you can use fprintf. It is something like we can use this one to write different things into the txt file, for example. But here you should have something like fopen txt file. Then you write fprintf some information, and then you write fclose or something like this. Maybe you see something like this one in Python, but here it is only just fopen, then f.write something, and f.close. Or you can use, I think, command with, something like with, f, open, and etc. So you can see if you write fprintf, then channel, here I use persons with %d. So it means my variable is integer, and here also integer. And this line checks the values. So for the first D, it is channel loop, and for the second D, it is signal to noise ratio in decibels. And this one is to move to the next clear line. So you can see these informations in command line, in this case, in command window. So let's start our algorithm, and you can see that we go through the first channel first with different decibels, then second channel, and then third channel. And as a result, so I think now we can, for example, increase the number of transmitted symbols, and then we will get the proper results. Because you can see we already have this very good shape of bit error rate for case 2x4, and we have some bad cases for case 2x2 here for high SNRs. It's strange. Maybe let's check it one more time. One more time in our code. 2x2. 2x2. This one. 2x2. H11, H12. Then H12 composite conjugate minus H22. H11 here. Then the second row, 1-1. I see. Here, we should use, of course, composite conjugate. Yes, great. So let's check now. And maybe let's increase, for example, up to 50,000 of transmitted QPSK symbols. So this type of command you can use for logging your algorithms. For example, in the beginning, you can use tick command. It will start something like clock. And at the end of your algorithm, you can use talk command. So it's just like tick and talk. And you will get how much time it is required to calculate your algorithm, for example. And for example, you use tick in this part. For example, for channel loop here, we write tick, something like a starter point. At the end of this SNR loop, we write talk, and this starter point also as indicated. And then using this fprintf, you can write to the txt file your logs, something like for channel 1, we need to, for example, 10 seconds to calculate everything. And maybe if you want, I can show you how to do it, of course. So yes, we end with channel 3. I hope. Oh, another one very strange case for 2 by 4. But why? So 2 by 1 is good. 2 by 2 better than 2 by 1. But we have this very strange 2 by 4. Let's check one more time. 2 by 4. Okay. 2 by 4. We calculate this thing here. 1 1 1 2 1 2 1 1 2 1 2 2 2 1 2 2 2 and 2 1 here. Like there are no things. Yes. With dimensions. No. If something wrong with dimensions, MATLAB give you some errors. Like I cannot calculate like A times B, and you have something wrong. It will give you error in this case. So maybe let's check comps conjugate, comps conjugate, comps conjugate, comps conjugate, 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 conjugate. Now it's really strange because in previous run it gave us right thing, but now it's wrong. Very strange. Maybe I will open one more time my homework number 3 here. Maybe I lose something here. One 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 two. 1 2 complex conjugate minus 1 1 complex conjugate. 2 1 2 2. 2 2 complex conjugate minus 2 1 complex conjugate. 3 1 3 2. 3 2 complex conjugate minus 3 1 complex conjugate. 4 1 4 2. 4 2 complex conjugate minus 4 1 complex conjugate. Maybe something wrong with y variables. Let's check. Maybe. Boom, 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 boom. Beautiful. So it is 4 by 2, yes. We have 2 receive antennas and 4 different times. Oh no, not like this one. We have 2 time slots, this one and this one, and 4 different antennas. Yes. So H24. Yes, it is 4 by 2 because from left side we write number of receive antennas, and from right side we write number of transmit antennas. So it's correct. X is with transmitted symbols. So first time symbol period and second time symbol period. So here we write minus this thing, but with keeping the sign of complex conjugate, and this one just complex conjugate. Everything is correct. Right now, everything is correct. Four by 2 times 2 by 2. We also have 4 by 2. 4 by 2, first one, which is first symbol period. Second one, it is second symbol period. So yes, in this case, we write it as 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, and 4, 2, of course, because we multiply our channel with first transmitted symbols, channel with second transmitted symbols, and etc. Really strange. Maybe here Z24. So it is something like we check the real part of receive symbol, the image part of receive symbol, so first one, second one, and we check it with real part of transmitted symbols. First one, here and here, and image part here and here. 1 and 1, 2 and 2, 1 and 1, 2 and 2. And of course we divide it by 2. Really strange. Next, maybe let's try to run it one more time. And of course, I can show you what I said before. As you remember, we run it as tick and with some trigger thing. No. We write here, for example, start time. Then we write tick. When we end our for loop, we can write, for example, here talk. No. End time is equal to talk of our start time. And for example, we can write here f print f overall time or channel number, in this case with d, is, and in this case we should use float. Let me check. f print f. Here, as I remember, first we show the number of elements before dot and after dot. This. No. Like this one. This one, seconds, for example. And here we write channel loop as if I'm not mistaken. Channel loop. Here and time. Something like this. Let's check it. Of course, I forgot about and here I should, yes, you can see that we write everything on one line because I did not add this thing here, starting from new line. So you can see it's approximately 20 seconds for all channels. If we assume, oh, this one is very good one. If we assume 20,000 of transmitted symbols, it is approximately 20 seconds. So 1 second for each 1,000 of symbols. Let's maybe end with, for example, if we increase the number of signal to noise ratio range, so we decrease the step and increase the number of SNR values, and let's increase the transmitted symbols. And then I think we will have quite good results for this homework number 3. So I leave you approximately to 5 minutes. I will drink some water and I will be back. Just 2-3 minutes, please. So what we have here, We need approximately 100 seconds for this type of simulations. So we need approximately another 3 minutes to get our results. So do you have any questions, guys? Maybe.
Not yet, I think.
Ah,
No, I think.
you have. Ah, okay. Mhm. Mhm. So we end with channel 2, and the last one, channel 3. And of course, using this fprintf is very good to see in which part, how to say it, maybe I will say it in Russian. Это очень хорошо использовать такой тип логинга. То есть если мы пишем fprintf, можно это, в принципе, писать либо в командную линию, либо в txt файл, как вам угодно. Это удобно, чтобы видеть, где, на каком этапе ваш код. То есть если, например, ваш код достаточно большой, ну, допустим, если вы рассчитываете прием и передачу какого-то сигнала, большого сигнала. We have a lot of errors. Например, вы рассчитываете вот большое количество передач сигналов, то, например, можно разделить задачу на 2 части. Часть передатчика и часть приемника. И можно добавить вот такие команды fprintf и указать что-нибудь в качестве логинга. И вы в командной строке будете видеть, как далеко прошел ваш код, чтобы не сидеть и не думать, считает он или нет. Но результаты достаточно странные, как и в прошлый раз. Но хотя бы видно то, что разница между количеством антенн есть. То есть одна антенна дает достаточно плохой результат. Увеличиваем антенну до 2, получаем уже получше. Увеличиваем до 4. То есть мы тут что можем сказать? За каждую передачу 1000 символов, используя 4 приемные антенны, мы получаем только одну ошибку, когда у нас сигнал шум равен 5, уже 5 дБ. То есть если мы увеличим количество, если мы сможем как-то увеличить наш сигнал шум, то при передаче 1000 символов мы будем иметь ошибку меньше, чем 1 бит. Вот. Но опять очень странно выглядит. Я не знаю, где-то проскакивает ошибка. Хорошо. Может, это слишком большое количество передач символов, конечно, влияет. Пусть будет до 10, допустим. Так. Это, наверное, будет последний прогон алгоритма, хотя он достаточно быстро идет. Посмотрим на результат. Ну, что-то типа, но больно он странно выглядит, конечно. Мгм. Если вернемся обратно к тем же вариантам. Так, что тут еще было? Угу. И все. Ну да, как бы здесь все то же самое, конечно. Ну, мы получили хороший результат, но опять-таки больно как-то 2.1 очень сильно отличается от 2.2, но при этом 2.2 очень сильно похож на 2.4. То есть 2.2, наверное, должен либо проходить чуть выше, либо 2.1 чуть ниже. Хотя 2.1 вряд ли чуть ниже будет проходить. за счет того, что у нас только одна антенна приемная. Ну ладно, допустим, пусть останется так. Может, я попробую переписать сам уже после того, как закончу со слайдами. Хорошо, хорошо. Так.
Ильдар Айдарович,
Да,
вам можно будет домашку прислать 2 файлами? Одна часть письменная, другая то, что из MATLAB.
ну, можно и так. Можете, в принципе, есть программы объединения PDF.
Угу.
Можете так объединить, если хотите.
Хорошо.
Как вариант, я еще пробовал... вы, наверное, пишете в LiveScript, да?
Да.
Ну да, там не получится, конечно, добавить фото.
Нет, там можно добавлять, просто там оно как-то странно добавляется, не очень красиво.
В целом туда можно добавить фото, и оно даже будет адекватно показываться.
Ну, можно, в принципе, отдельно отправить. Но будет неплохо, если вы совместите, допустим. Это, ну, для упрощения проверки.
Ильдар
Но-
Айдарович, вам
да.
можно будет сегодня отправить свою PDF-ку с домашкой, чтобы вы просто посмотрели хотя бы графики на адекватность результатов?
Хорошо, можно попробовать.
Спасибо.
И что вам... Отпишусь, похожи они на то, что предполагалось увидеть или нет.
Спасибо.
Так. Наверное, на этом все. Спасибо, что присутствовали в этой практике. То, что продолжали слушать. И да, ну вот, я советую, наверное, пока что может сконцентрироваться вам на следующем экзамене. То есть лучше подготовьтесь к 15 числу, допустим. А после 15 числа уже скоординироваться с группой и обсудить, если у вас вопросы, если они возникнут. Мне кажется, лучшим вариантом является назначить что-то по типу консультации это на пятницу, потому что в таком случае у вас еще будет 3 дня, ну, учитывая саму пятницу. Вот, как-то так. Наверное, так. Ну, в моих мыслях.
Да, вполне разумно звучит. Тогда там ближе к делу посмотрим. У нас 15-го первый экзамен Артур Камильевич, потом 20-го у вас.
Угу, хорошо, хорошо. Тогда хорошего вам вечера.
А вам лучше в Телеграме вот сейчас отправить на проверку или на почту?
Лучше на почту. Я почту проверяю несколько раз в день. В лучших случаях даже почаще проверяю. Вот просто в последние 2 дня не получалось так часто заходить на почту.
Угу.
Но вот во второй половине недели, скорее всего, я много буду проверять. Часто буду проверять.
Ладно, хорошо, тогда ждем от вас
Хорошо, хорошо.
комментариев.
Угу.
Всё, спасибо большое.
Хорошо, тогда до свидания. Если других вопросов нет,